These are your notes for pre-calculus for Unit 7, Day 2B. If you would like to see the warm-up, review question, or any homework questions we covered in class today, just look at the finish notes. So today we are going to continue solving different types of trig equations. And we will do them algebraically, so without the aid of a calculator, and then with the aid of a calculator or Desmos. All right, so these are some review from what we did from 7.1 and 7.2. So our arc trig functions. And remember, if you want to find the inverse cosine of 1, you're asking yourself, what angle for cosine would give you a value of 1? And remember, inverse cosine or arc cosine, they mean the exact same thing, only exists between 0 and pi. So remember when we graphed cosine, we had to restrict it to be between 0 and pi so that it would pass the horizontal line test. So when you're trying to find values for inverse cosine or arc cosine, you are just looking for values of that angle in the first two quadrants. So if it's positive, you're in the first quadrant. If it's negative, you're in the second quadrant. So we want cosine to be 1. Well, cosine has a value of 1 at 0 degrees or 0 pi. So cosine is 1 at 0 or 0 pi. And that is just from the table. The next one says, what is the inverse tangent of square root 3 over 3? So we are asking what angle for tangent would make square root 3 over 3. And then if you remember, inverse tangent or arc tangent, when we restricted that, we restricted it to be between pi over 2, so you would rotate up to pi over 2, or rotate down to negative pi over 2. So inverse tangent only exists in the first and fourth quadrant. So if you want it to be positive, you're in the first quadrant. If you want it to be negative, then you would rotate down to the fourth quadrant. And so tangent is square root 3 over 3 at 30 degrees, which is pi over 6. So the value for tangent that would give you square root 3 over 3, and that is in the first quadrant, would be pi over 6. The next one's asking when, for what angle value of sine do you get sine to be 1/2? And then inverse sine or arc sine is just like tangent. So when we restrict it to be between negative pi over 2 and pi over 2. So again, arc sine would exist in the first quadrant up to pi over 2 and down in the fourth quadrant to negative pi over 2. So sine gives you a value at 1/2 at pi over 6 or 30 degrees. And so that would be your answer for those. All right. And then we also found these types of problems when they weren't from the table. So what is the tangent of the inverse sine of 4/5? So remember, 4/5 is not from our table. So when it's not from the table, you need to make a right triangle and solve for the missing side. So you need to make a right triangle, and we can put theta in the corner. So we're going to make a right triangle. And sine, remember, is SOHCAHTOA. So sine is going to be opposite over hypotenuse. Well, the opposite side is 4, because this is your opposite over hypotenuse. So the opposite side's 4, the hypotenuse is 5, and then theta is going to be down in the corner. And so when we're finding the inverse sine of 4/5, we're trying to figure out that angle, or we're trying to solve for that triangle. So 4 squared plus a squared equals 5 squared using the Pythagorean theorem. So 16 plus a squared equals 25. Subtract the 16 over, and a squared is going to be 9, so a is 3. So that missing side, the adjacent side, is going to be 3. So now it wants to know the tangent of that angle. Well, tangent is TOA, so it's opposite over adjacent. So the tangent of the inverse sine of 4/5 is going to be the tangent of that angle that we just found. So it's going to be 4/3, 4 over 3, opposite over adjacent. And so this value right here, the end value would be 4/3. All right, another example, find the cosine of the arc sine of square root 5 over 13. Well, again, arc sine is inverse sine, so we want to find the inverse sine of square root 5 over 13. That is not from the table, so we're going to make a right triangle. Sine is so opposite over hypotenuse, so square root 5 over 13. And then we can use the Pythagorean theorem to find our missing side. So square root 5 squared plus a squared equals 13 squared. So 5 plus a squared equals 169. Subtract the 5 from both sides. So a is going to be the square root of 164. So that missing side is the square root of 164. And now we want to find the cosine of the angle in that triangle. Cosine is adjacent over hypotenuse. So adjacent is square root 164, and then over the hypotenuse 13. So the final value for this problem would be the square root of 164 over 13. And again, those two slides are from section 7.1 and 7.2 in our book. So what we did 2 classes ago. All right, so what we did last class is we solved trig equations. So remember our steps. The first step is you want to get sine or cosine or tangent alone if possible. So if you can get the trig function alone on one side of the equation, do it. So in that first one, 2 cosine x equals square root 2. To get our cosine value by itself, we're going to divide both sides by 2. And then we have cosine x equals square root 2 over 2. So now my cosine is by itself. Then step 2 is you need to find the 1 or 2 values that make that equation true. And so in order to do that, you use the table, and then you can use that starburst or the thing that's going to be right below us in order to find the 2 values where cosine of our angle is square root 2 over 2. Well, from our table, we know cosine is square root 2 over 2 at pi over 4. And then it's positive square root 2 over 2. So we need the 2 quadrants where cosine is positive. Well, all students take calculus. Cosine is positive in the first quadrant and in the fourth quadrant. So we need to find the values of pi over 4. Well, in the first quadrant, it's just normal pi over 4. And then in the fourth quadrant, so if we go down to the starburst, in the first quadrant, pi over 4 is right here, 45 degrees. And then in the fourth quadrant, the 45 is right here, which is at 7 pi over 4. So the other value of cosine where you would get square root 2 over 2 would be 7 pi over 4. And so those are the 2 values we want. And then step 3, remember you add and subtract whatever the period is. So for cosine and sine, it would be 2 pi, and then times k, where k can be 1 or 2 or 3 or 4. So you're going to add 2 pi, and then you can add 2 pi again, and then you can add 2 pi again and again and again. And that would give you all of the values that would make this equation true. So the period, remember for sine, cosine, secant, and cosecant, the period would be 2 pi. And then for cotangent and tangent, the period would be pi. So for these, since we're doing cosine, it's going to be plus or minus 2 pi times k and plus or minus 2 pi times k. So those would be the solutions to that equation. All right, for our next one, we have 2 times sine x plus square root 3 equals 0. So we want to try and get that sine x by itself. So we're going to subtract the square root of 3. And then we have 2 sine x equals negative square root 3. And then divide both sides by 2. And so sine x is going to equal negative square root 3 over 2. So now sine is by itself. So we want to find the 2 places where sine would be negative square root 3 over 2. Well, sine is negative. So what quadrants is sine negative in? Well, sine is negative in the third quadrant and the fourth quadrant. And now we want from our table, when is sine square root 3 over 2? Well, sine is square root 3 over 2 at 60 degrees or pi over 3. So we need the pi over 3s that exist in the third quadrant and the fourth quadrant. So let's scroll down. And where are the pi over 3s in the third quadrant and the fourth quadrant? Well, here's one. So at 4 pi over 3, and then here's the other one at 5 pi over 3. So the 2 values that I want for my angle are 4 pi over 3 and 5 pi over 3. So my angles are going to be 4 pi over 3 and 5 pi over 3. And then you add or subtract the period times k. Well, it's sine, so the period is going to be 2 pi. So plus or minus 2 pi k and plus or minus 2 pi k. And so those would be my solutions to 2 sine x plus square root 3 equals 0. All right, let's look at some more examples. Now, these are calculator problems. So let's remember how to solve these using our calculator. So if we want to solve sine x equals 0.119, to get the angle by itself, you inverse sine both sides, and that would give me one of the solutions. So on our calculator, we would take the inverse sine of 0.119 and make sure you are in radians. So we are in radians. And so we're going to do the inverse sine of 0.119. And remember on your calculator, that is second sine or shift sine. And this is going to be 0.1193. And then plus or minus 2 pi k. And then remember to get your second solution for a sine, because remember we need two solutions. So the second solution for sine, you do pi minus the first solution. So to get your second solution, we're going to do pi minus our first solution, and our first solution was 0.1193. And so our second solution is going to be pi minus 0.1193. And our second solution is going to be 3.022, and then plus or minus 2 pi k. And so our two solutions for when sine x is 0.119 is 0.1193, and then plus or minus 2 pi k, and then 3.002 plus or minus 2 pi k. And I can prove this, and remember, we can show this on the calculator. We can graph 1, so we can graph sine x, and then we can graph what I want it to equal, and I want it to equal 0.119. And so our solutions, notice we get 0.119, and then our second solution is 3.022. All right, so that's how you do it for sine. You find inverse sine on your calculator, and then the second solution is going to be pi minus the first solution. That's how you can get your second solution for sine. For cosine, again, your first step is we would take the inverse cosine of both sides. And so x is going to be, now we go on our calculator, and we do the inverse cosine, and make sure you're in radians. We're going to do the inverse cosine of 0.257. And so my first solution is 1.31, and then we'll do 0.9. And then the period for cosine is 2 pi, so plus or minus 2 pi k. And then your second solution for cosine, you can do two different things to get your second solution. You can do 2 pi minus the first solution, or you can do the opposite of the first solution. And I think that's the easier way of doing it. So my second solution is just going to be the opposite of the first solution. So negative 1.13109, and then plus or minus 2 pi k. And those could be my two solutions, and then plus or minus the period k. The good news for tangent, you only need to find one solution. So for tangent and cotangent, you only need to find one solution. So to find one solution, we're just going to take the inverse tangent on both sides. And so x is going to be the inverse tangent, and remember, make sure you're in radians, 0.578. So the inverse tangent of 0.578 is 1.399, and then plus or minus the period, and the period for tangent is pi. So the period for tangent is pi. So it's going to be plus or minus pi k for tangent. And so those would be how you could solve these types of problems using your calculator. So if they're not from the table and you have to use your calculator, that's how you could do it for sine, cosine, and tangent. All right, let's go back to ones that we can solve by hand or algebraically. So remember, your first step is you want to get your trig function by itself. So let's subtract the 1 from both sides, and we would have negative 4 times the sine of x over 2 equals 2. And then divide everything by negative 4. And so sine of x over 2 equals negative 1/2. So now we have the trig function sine by itself. So we want to know when sine is negative 1/2. So we need sine to be negative. Sine is negative in the third quadrant and the fourth quadrant. And then sine is 1/2 at our pi over 6. So we need the pi over 6's that occur in the third and the fourth quadrant. So let's go down to our star. And the pi over 6's, or the 30 degrees that occur in the third and fourth quadrant, would be 7 pi over 6 and 11 pi over 6. So those are going to be the two solutions that I want. So I need x over 2 to equal 7 pi over 6 plus or minus 2 pi k, or I need x over 2 to equal 11 pi over 6, and then plus or minus 2 pi k. And notice it's not just x this time, it's x over 2. So we're going to use that x over 2 as the last step. So now to solve for x, to get rid of dividing by 2, multiply everything by 2. So I'm going to multiply everything by 2 and multiply everything by 2 in the second one as well. And so I get x is going to equal 14 pi over 6, then plus or minus 4 pi k. And I can simplify that fraction into 7 pi over 3. So 7 pi over 3 plus or minus 4 pi k. That would be one of my solutions. And then the second one, multiply everything by 2, and you get 22 pi over 6, then plus or minus 4 pi k. And if I simplified that fraction, I'd get 11 pi over 3 plus or minus 4 pi k. And so that would be my other set of solutions. All right, we have tangent 3x equals negative square root 3. So again, the trig function's already by itself, so we want to know when tangent's negative. And remember, for tangent, you only have to look in the first and second quadrant, because tangent repeats itself after that, because the period is equal to pi. So I only have to go between 0 and pi to look for tangent. And I want it to be negative. Tangent's negative in the second quadrant. And tangent is square root 3 at 60 degrees, so pi over 3. So I need the pi over 3 in the second quadrant. So the pi over 3 in the second quadrant is going to be right here, which is 2 pi over 3. So I need 2 pi over 3. So I have 3x equals 2 pi over 3, and then plus or minus the period. The period for tangent is pi, so plus or minus pi k. And so now our last step is we need to solve for x, so we have to get rid of the 3. So we're going to divide everything by 3. So x is going to equal 2 pi over 9, and then plus or minus pi over 3k. And so that would be my equations that would work for that equation. And again, you can show on Desmos this works. So we would graph one side, y equals tangent 3x. And then on the other side, we're going to do y equals negative square root 3. And then we want to know where these intersect. So we can blow this up a little bit. And so that first intersection point, notice, is 2 pi over 9, which is what we got, then plus or minus pi over 3. So to get my next solution, I would add pi over 3, and 2 pi over 9 plus pi over 3 would be 5 pi over 9, which would be my next solution. So we went from 2 pi over 9 to 5 pi over 9. All right, let's look at some more equations. All right, so one that looks like this, we have a cosine squared and we have a cosine. So I can't get the trig function by itself. So this is one of the ones where we're going to have to factor. So let's subtract the 8 over. And we have 5 times the cosine squared of x plus 6 times cosine x minus 8 equals 0. And I'm going to let w equal cosine x so I can factor this more like a quadratic. So if I replaced cosine x's with w, I would get 5w squared plus 6w minus 8 equals 0. And then I can factor this. So I need two numbers. When I multiply them, I get negative 40. And when I add them, I get 6. So I can break up 6w into 10w minus 4w, because 10 times negative 4 is negative 40, and 10 plus negative 4 is 6. And then we have the 5w squared, and then the minus 8. And then to factor by grouping, group the first two, group the second two, plus sign in the middle. And we can factor out a 5w, and we get w plus 2. And then I can factor out a negative 4, and I get a w plus 2. So I have 5w minus 4, and w plus 2 equals 0. So my two solutions would be w equals 4/5 or w equals negative 2. But remember, we said w was cosine x. So now I'm going to take those, and I'm going to say that cosine x equals 4/5 or cosine x equals negative 2. And since neither of those values are from the tables, in order to solve, we're going to do the inverse cosine on both sides. And so the inverse cosine of 4/5, and again, make sure you're in radians, the inverse cosine of 4/5 would give us 0.6435. and then plus or minus the 2 pi times the period times k, so 2 pi k. And then remember, to find your second solution for cosine, you can just do opposite of the first solution, so negative 0.6435 plus or minus 2 pi k. And so those would be some of my solutions. And then we would do the inverse cosine for the second one. And then if we did the inverse cosine of 2, or negative 2, watch what happens. We get undefined. This one's not going to have any solutions, because do you remember when we graphed cosine? So y equals cosine x. Cosine stays in between -1 and +1. So if I try and figure out where it intersects -2, notice cosine x and -2 never intersect each other, so they're never going to have any solutions. So cosine x has to fall somewhere between -1 and +1 to have solutions. So the only solutions from that would come from the cosine x equals 4/5 side. All right, let's look at another one. On this one, we have one side equal to 0, so let's let x equal sine theta. So if I rewrote this, I would have 2x squared plus 3x plus 1 equals 0. And I can break up that 3x into 2x and 1x, and then we have the plus 1 and the 2x squared. And then factor by grouping. I can factor out a 2x, and I'd have x plus 1. I can't factor out anything, but I can factor out a 1, and I'd still have an x plus 1. So I'd have 2x plus 1 times x plus 1 equals 0. So either x is -1/2 or x is -1. But remember, we said x was sine theta. So either sine theta equals -1/2 or sine theta equals -1. All right. When does sine x or sine theta equal -1? Well, sine is negative in the third quadrant and the fourth quadrant. And it's 1/2 at the pi over 6. So what are the pi over 6 in the third and fourth quadrant? Well, the pi over 6 in the third and fourth quadrant are 7 pi over 6 and 11 pi over 6. So theta equals 7 pi over 6, then plus or minus 2 pi k. Or theta equals 11 pi over 6 plus or minus 2 pi k. So those are going to be my solutions from that equation. And then when does sine theta equal -1? Well, sine theta equals -1 at only 3 pi over 2. And so my other solution would be 3 pi over 2 plus or minus 2 pi k. All right. Tangent x times secant x plus 3 tangent x. I can't get either of those trig functions by himself, but if you notice, this is another factoring problem. It's a common factor problem. What do these two pieces have in common that I could factor out from both of them? I can factor out a tangent x from both of them. So if I take out a tangent x, then I'm left with secant x plus 3, and then equals 0. So now either tangent x is equal to 0 or secant x plus 3 is equal to 0. Well, remember, tangent x, you only need to get one solution, and tangent is 0 at 0, so that's going to give me 0, and then plus or minus the period k. The period for tangent is pi, so those solutions would be 0 plus or minus pi k. And then for secant, I don't like dealing with secant, but remember, secant is the same thing as 1 over cosine, or cosine is the same thing as 1 over secant. So what I can do is I can do the reciprocal. Well, let's get secant by itself first. So I'm going to subtract the 3 and subtract the 3. And so now I have my trig function by itself. Secant x is equal to -3. And then remember, secant is the reciprocal of cosine. So if I take the reciprocal of both sides, then I get cosine x equals the reciprocal of -3, which would be -1/3. Well, that is not from the table. So in order to solve this, I'm going to do inverse cosine on both sides. And so x is going to equal the inverse cosine of -1/3. And the inverse cosine of -1/3 is 1.9106. And then plus or minus 2 pi k. And then remember, to get your second solution for cosine, you can do opposite of the first solution. So -1.9106 and then plus or minus 2 pi k. So this equation would have 3 solutions and then plus or minus the different periods k. So this is an example of a common factor that you would have to factor out first. All right. Let's look at another one. So cosine squared minus sine squared plus sine equals 0. So notice we have two different trig functions again, but there isn't a common factor that I can factor out of all of those. So this is one of the ones where I can replace. So if you remember, cosine squared is the same thing as 1 minus sine squared, and sine squared is the same thing as 1 minus cosine squared. So those are two identities that will help us solve these types of equations. So what I'm going to do is I have two sines, so I'm going to replace this cosine squared with 1 minus sine squared. So I'm going to substitute 1 minus sine squared in for that cosine squared. And then I still have minus sine squared x, and then plus sine x is equal to 0. Combine like terms, and I have negative 2 sine squared x plus sine x plus 1 is equal to 0. All right, I'm going to replace, so I'm going to let w equal sine x. So I have negative 2w squared plus w plus 1 is equal to 0. And then I can factor by grouping. So I need to be able to multiply to negative 2 and add to 1. So this would be positive 2 and negative 1. So I have positive 2w minus 1w, then plus w, and then minus 2w squared equals 0. And then we can factor by grouping. Group the first two, group the second two, plus sign in the middle. I'm going to factor out a negative 2w, and I have w minus 1. And then I'm going to factor out a negative 1, and I would have w minus 1. So I have negative 2w minus 1 times w minus 1 equals 0. And then if I solve both of these, I've got w equals negative 1/2 or w equals 1. Plug the trig function back in. And we have sine x equals negative 1/2 or sine x equals positive 1. All right, we want to know when sine is negative 1/2. Well, sine is negative in the third and fourth quadrant, and it's a half at the pi over 6's, and we've done this a couple times now. So this is 7 pi over 6 and 11 pi over 6. So x is going to equal 7 pi over 6 and then plus or minus 2 pi k, or x is going to equal 11 pi over 6 plus or minus 2 pi k. So those would be those solutions. And then sine x is equal to 1 at 90 degrees, or pi over 2, and that's the only time on the unit circle that would happen. So my three solutions are 7 pi over 6, 11 pi over 6, and pi over 2, and then plus or minus 2 pi k. All right, next one we have sine squared x plus 3 cosine squared x is equal to 0. So I am going to replace the sine squared with 1 minus cosine squared. So this is going to become 1 minus cosine squared, and then plus 3 cosine squared equals 0. Combine like terms, and I have 1 plus 2 cosine squared x equals 0. Let's get our trig function by itself, so we'll subtract 1 from both sides. And I have 2 cosine squared x equals negative 1. Then divide both sides by 2, and I have cosine squared x equals negative 1/2. Well, it's cosine squared. To get rid of something squared, you can take the square root. So we'll take the square root of both sides and then plus or minus. So cosine x is going to equal plus or minus the square root of negative 1/2. Well, you can't take the square root of a negative number because those aren't real. So this will give me no real solutions. I would get imaginary answers, but not real solutions. Okay. Let's look at the next ones. We have 4 secant theta plus 6 is equal to negative 2. So let's get the secant theta by itself. So let's subtract 6 from both sides. And I have 4 secant theta equals negative 8. And then divide both sides by 4. And so secant theta is going to equal negative 2. I don't like looking at secant, so I'm going to do reciprocals on both of these. The reciprocal of secant is cosine, and then the reciprocal of negative 2 is negative 1/2. So we want to know when cosine is equal to negative 1/2. Well, cosine is negative in the second quadrant and the third quadrant, and it's 1/2 at the pi over 3. So I need the pi over 3's that exist in the second quadrant and the third quadrant. So the pi over 3's that exist would be 2 pi over 3 and 4 pi over 3. So those are the 2 pi over 3's that I want. So 2 pi over 3 and 4 pi over 3. So theta is going to equal 2 pi over 3 plus or minus 2 pi k. And theta is going to equal 4 pi over 3 plus or minus 2 pi k. All right, let's look at our next one. Secant of 3 pi over 2 equals -2. So secant's already by itself, but let's do reciprocals. So we're going to do the reciprocal of secant, which is cosine. So this cosine of 3 pi over 2, the reciprocal of -2 is -1/2. And so we want to know when cosine equals -1/2. We just found those. So we're going to say 3 pi over 2 equals 2 pi over 3 plus or minus 2 pi k. And 3 theta over 2 equals 4 pi over 3 plus or minus 2 pi k. So those are just the ones we found on our previous problem. And so remember, you take that 3 theta over 2 and then solve for theta. So to get rid of 3 theta over 2 and just have theta, we're going to multiply everything by 2 over 3, the reciprocal. So theta is going to equal 2 times 2 pi is 4 pi. 3 times 3 is 9, so that's going to become 4 pi over 9. And then plus or minus 4 pi over 3k. So that's going to be one of my solutions. And then multiply the bottom one by 2 pi over 3, and we get theta equals 2 times 4 pi is 8 pi, 3 times 3 is 9, then plus or minus 4 pi over 3k. All right. Let's solve these. So now we have 4 cosine squared theta equals 1. Let's get the trig function by itself. So let's divide both sides by 4. So I have cosine squared theta equals 1/4. And then to get cosine by itself, let's take the square root of both sides. So plus or minus. So cosine theta is going to equal plus or minus the square root of 1/4. The square root of 1 is 1. The square root of 4 is 2. So that's going to be plus or minus 1/2. So either cosine theta equals -1/2 or cosine theta equals +1/2. Well, all students take calculus. Let's do the negative one first. So cosine is negative in the third quadrant and the second quadrant, and it's 1/2 at the pi over 3's. So this is going to be 2 pi over 3 and 4 pi over 3. So theta is going to equal 2 pi over 3 plus or minus 2 pi k, or theta is going to equal 4 pi over 3 plus or minus 2 pi k. And then when is theta +1/2? Well, when is cosine +1/2? Cosine's positive in the first quadrant and the fourth quadrant, and it's 1/2 at the pi over 6. So pi over 6, and then pi over 3, not pi over 6. So pi over 3 in the first quadrant, and then the other pi over 3 would be 5 pi over 3 in the fourth quadrant. So my solutions for this one would be theta equals pi over 3 plus or minus 2 pi k, and theta equals 5 pi over 3 plus or minus 2 pi k. So that one has 4 solutions. All right. Tangent squared theta equals 1/3. So to solve for tangent, we're going to take the square root of both sides, so plus or minus. So tangent theta equals plus or minus the square root of 1/3, which is the square root of 1 over the square root of 3. And then if you rationalize this, you get square root 3 over 3. So we want to know when tangent theta equals plus or minus square root 3 over 3. So tangent theta equals negative square root 3 over 3, or tangent theta equals positive square root 3 over 3. Well, tangent is going to equal, and remember, we only have to look in the first and second quadrant for tangent. Tangent is negative in the second quadrant, and it's square root 3 over 3 at the pi over 6, and the pi over 6 in the second quadrant is 5 pi over 6. So this is going to be theta equals 5 pi over 6 plus or minus pi k, because the period for tangent is pi. And then the other one, tangent is positive square root 3 over 3 in the first quadrant, and it's the pi over 6. So this would be pi over 6, and then plus or minus pi k. So that would be my solutions to that equation. All right. What if we have secant squared theta plus tangent is equal to 0? This is another replacement. 1 plus tangent squared theta is going to equal secant squared theta. So 1 plus tangent squared equals secant squared is the original problem. So I can replace this secant squared with 1 plus tangent squared. And that is, if we go back to our day 2, unit 2 notes, and we go back to right here, that was one of the formulas. So Tangent squared plus 1 equals secant squared, or secant squared equals 1 plus tangent squared. So that's the formula that I'm using for these. And so I'm going to replace that secant squared with 1 plus tangent squared. So I have 1 plus tangent squared plus tangent theta equals 0. So let's rewrite this. Tangent squared theta plus tangent theta plus 1 equals 0. And then I'm going to let x equal tangent theta. So if I rewrote this, I'd have x squared plus x plus 1 equals 0. All right, can I multiply to 1 and add to 1? I can't, so I'm going to have to use the quadratic formula. So x is going to equal the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. A is going to be 1, b is going to be 1, and c is going to be 1 because we have 1x squared, 1x, and 1. So x is going to equal negative 1 plus or minus the square root of 1 minus 4 times 1 times 1 all over 2 times 1. So x is going to equal negative 1 plus or minus the square root of negative 3 over 2. And again, on this one, we're going to get imaginary solutions because we have a negative under a radical. So this is going to have no real solutions. All right. Your homework is to continue working on your 7.3 homework. Let me know